Today's lesson is about properties of integers. You can remember from lesson 1.1 we've already had an introduction to integers this year. They were defined as the whole numbers and their opposites. We can show it on a number line. 0 is a whole number, and 1, and I should put a dot there because it doesn't include the spaces in between, and 2, and then we can go to the left. Negative 1 is an integer. Negative 2 is an integer. We could also name them this way. 0, 1, 2, dot, dot, dot. Negative 1, negative 2, dot, dot, dot. So that's sort of just a quick review of what integers are. Now let's talk more about their properties. The word opposites in algebra, pre-algebra, can mean different things. It can be opposite operations, but when we talk about integers, we talk about two numbers that are opposites if they add up to 0. So 3 plus negative 3 equals 0. And in general, a plus the opposite of a equals 0. Another way to define them is to say there are two numbers that are the same distance from 0 on the number line. So the opposite of 10 would be negative 10 because they're both 10 units away from 0. But I kind of like this definition of understanding because it has a lot to do with the addition property of equality, because 3 and negative 3 make a 0 pair, and that's pretty significant in solving equations. The absolute value of a number is how far it is from 0, the distance that the number is from 0, and it's always a positive number. You can find the absolute value of a negative number, but it's always going to be, once you call it absolute value, it's always a positive number. So we have 0 on our number line, and if we talk about positive 15, then this is a symbol that means the absolute value of 15. So the two brackets, two vertical brackets, and then the number inside. This is read as the absolute value of 15. This is read as the absolute value of negative 15. And this is read absolute value of negative 1. And to calculate it, you just say, here's 0, and how far is 15 from 0? Well, the answer is 15. So that's a pretty simple one. They're all pretty simple, actually. So how far is negative 15 from 0? Well, here's 0 and negative 15 over here. It's also 15 away from 0. Absolute value, remember, is always positive. So think about what's the absolute value of negative 1. And the answer is, of course, positive 1. We'll be graphing some integers in today's lesson. It's just a quick review of the symbols greater than, less than. So this is greater than. And less than goes the opposite direction. And just keep in mind, of course, that's equals. So he had a statement that said, graph the integer, some integer x that equals negative 6. This is pretty simple. It just means draw a number line, put a 0, put negative 6, and just put a dot there. So that's a graph of 0, the number x, which is equal to negative 6. Then we'll look at some things a little bit more complicated, double inequalities, in the next slide. The name double inequalities implies that there's two inequalities. So we're going to have a math statement that says something like, we're thinking of a number, and it's less than 6, let's say that, and the number can be greater than negative 2. So you can read this statement in the following way. Negative 2 is less than n, and n is less than 6. When you have double inequalities, 1, 2, these symbols must be the same. You wouldn't put like less than symbol here and a greater than symbol here. It wouldn't make sense if you tried to graph it. So to graph this, you can also, another way to read this, which is going to help you use logical reasoning to put this on a graph. You can start here and read n is greater than negative 2, and n is less than 6. Now that probably should make a lot of sense to you. So the way we graph it is to break it down, draw the number line. You have to put a 6 on it. It's always nice to put a 0. And then you can kind of use your intuition about, you might have graph paper and you can set it up with equal intervals, but if not, if you're just sketching it out, you can do it this way. So we know that the number is greater than negative 2 and less than 6, so it can't include negative 2. And if we're just talking about integers, we have to, this is a little tricky here. I'm going to have to put these other spaces in here. So there's negative 1, 1, 2, 3, 4, 5, and 6. So I don't include these endpoints. I'm not going to include negative 2 because the number is greater than negative 2, but it doesn't include negative 2. And the number is less than 6, which means 6 is not going to be in the set of numbers that meet this criteria here. So all these other numbers do, negative 1, 0, 1, and 2, and 3, 4, and 5. Now why didn't I just shade it? Why didn't I just do this? Shade them all in, not including the 2 and the negative 6, because then I'm doing all the rational numbers in there, and like from 1/2 is not included in the solution because we're working with integers. If the directions were, what are the integers between negative 2 and 6, then we just have to put the dots right on the integer values.